Now, you've already hopefully watched those other videos, so I want you to pause this video and take a minute and try to jot down all of the functions that you can think of for skin. And then turn the video back on and we'll see if you missed anything, or maybe you thought of something that wasn't on the list. Okay, so let's assume that you paused, you made your own list, and let's see how you did. So there are lots and lots of functions for skin. It certainly helps us to maintain homeostasis of several different things. It helps to act as a barrier. We talked about that with the bacteria. This is kind of our number one barrier that's helping to protect the body. It has a lot of sensory receptors. That's really important because if I grab a hot pan handle, it lets me know very quickly that I better let go of it before I burn myself. But on a more positive note, if you think about that first time you ever went on a date, there's a fairly good chance that it was to a movie, unless it was in the middle of the coronavirus pandemic and then you couldn't go anywhere. But let's say you went to a movie, because a lot of teenagers are kind of chicken and they don't want to actually have to have a conversation on a first date, right? So we'll go to a movie where we don't have to talk to each other. And then, halfway through the movie, you sort of sit awkwardly in your chair with your hand on your knee. Nobody sits like that normally. And you're just kind of seeing if maybe that other person's pinkies brush up against yours. And if they do, and they kind of pull their hand away, then you're in the friend zone, and that's fine, and watch the rest of the movie and move on. But if the pinky stays there, nothing else needs to happen, but you will be high as a kite for another week or two. So those sensory receptors are really important. You actually have more sensory receptors on your hands than all of your reproductive organs combined. The only place that really has more sensory receptors would be the surface of your eye. However, the difference there is all of those receptors are pain receptors, so don't get any ideas about pinky eyeball touching or anything weird like that. It does excrete some waste, but it's a very small amount, and as you saw from the other video, there's not really any solid evidence that increasing how much you sweat increases that waste loss through skin and sweat. Helps you to produce vitamin D, and you need vitamin D so that you can absorb calcium. And it helps us to regulate body temperature. So let's think about that. A significant amount of your blood is actually in the skin at any point in time. And remember that blood runs about a degree or two hotter than the rest of the body. So we're producing lots of heat from our skeletal muscle, from other metabolic actions within the body. And we need to get rid of that heat if we're too warm. And we want to conserve that heat if things are too cold. Now we're not going to worry about the hypothalamus right now because we haven't talked about that yet, but we will get into that later on in the semester. But what does your integument do if you're too warm? Well, if you're too warm, you might think, oh, I sweat. And that's true, but the sweat itself isn't what cools you down. It's when that sweat evaporates that it cools you down. Because you get something called evaporative cooling. It takes a tremendous amount of energy, heat energy, to warm up water enough to go from that liquid of sweat into a gas. So it draws that heat out of your body and cools you down. Now that's useful to know if you have somebody who's overheating. Getting wet, it doesn't have to be ice cold water, can help them to cool down because the evaporation of that water will cool them down. The other thing that I do is that I'm going to increase blood flow to the skin when I'm too hot. So that extra heat goes to the surface of my skin, warms up that water, and helps it to evaporate. So what can your integument do if you're too cold? Well, I can shiver, which technically isn't your integument. That would be skeletal muscle under the integument. My hair stands up, and that's going to help to trap warm air, closer to the surface of the skin so you don't lose as much. And I'm going to increase blood flow to the core. So I'm going to shunt that blood in towards my essential organs so that I don't lose too much heat. And that's why your fingertips and your toes always get cold first. So as we said, as your blood temperature or body temperature goes up, I'm going to send signals to my hypothalamus. That's going to cause vasodilation of blood vessels in the skin. So more blood goes to the skin, and I'm going to release that sweat and it's going to evaporate. If my body temperature falls, my hypothalamus helps me with vasoconstriction of blood vessels to the skin, so less blood can get out here. My sweat glands get turned off so they're not sweating, and my muscles that are underlying the skin are going to involuntarily shiver, and that's going to generate some heat. Let's take a quick tour of the skin, because you're going to need to be able to identify these structures. So let's take a look at the skin here. Up here, we have the hair shaft, which is basically just a bunch of protein called keratin. The tube that hair is kind of locked into in the skin is called the follicle. So the hair is down here and it's going to grow at the follicle, but this is just a bunch of protein. No cells up there. We have different layers. This layer that's kind of peeled up here is going to be my epidermis. We'll talk more about that later. And then my dermis. And finally, my hypodermis, or subcutaneous layer. Now, you'll notice that we see the larger blood vessels down here in the hypodermis, and they travel up into the dermis, but there are no blood vessels in the epidermis. So I can scratch or cut my epidermis and not bleed at all. That means that all of my epidermal cells are going to have to receive nutrients by diffusion of nutrients and molecules coming up from the dermis. This hair follicle has its own muscle right here. So every hair follicle has its own muscle called an erector pili muscle, because another name for this hair shaft that's sticking up is a pili. So the erector pili muscle pulls on that hair follicle and makes the pili stand up. We have a couple of different kinds of glands, and we'll talk more about them in a little bit more detail later. But we have this kind of coiled looking one here that looks like a little coiled snake, and it has its own duct to the surface, and there's another one over here. This gland is a sudoriferous gland, also known as a sweat gland. And there are some different types of sweat glands that, like I said, we will talk about in a little bit. The other type of gland that we see is often associated here with the hair follicle, and that is called a sebaceous gland. Sudoriferous glands produce sweat, sebaceous glands produce oil. Like I said, they're often associated with the hair follicle, which is why if you get, let's say you shave or wax or some other way, kind of remove this hair here, and the dead skin ends up covering up that pore, it means that that oil can't get out, and you can get an inflamed or infected sebaceous gland, which is also known as acne. We mentioned that there are important sensory receptors in skin. There are some here that don't even kind of end in anything. Some of them look like a little thumbprint or fingerprint sticking out. Some are a little bit bigger, more like a thumbprint. And then some of them are just little kind of dead ends. These little empty tree branches, if you will, these are called nociceptors. And these are pain receptors. So you notice they're right underneath that epidermis. And that allows me to feel acid, burn, cut, anything that's going to let me know very quickly that something harmful is out there. And then also relatively close to the epidermis, I'm going to have what we call the Meissner's corpuscles, or tactile corpuscles. So let me change a color here so it's a little easier to see. So this is a Meissner's or tactile corpuscle, or also known as a light touch receptor. And then over here, deeper under the skin, and often we'll even see them way down here, this then would be a Pacinian corpuscle or lamellar corpuscle. And these are going to be more for deep pressure. So those are kind of the major structures that we see within the skin. So we'll stop there, and then we'll come back and we'll get into a little bit more depth with some of these layers and structures.